So we talked about what absolute value is. Talked about how to graph absolute value functions, and now we'll talk about how to solve absolute value equations. You don't have to write this down, but I gave this to you a while ago when we did lesson 6.1. There's an absolute value equation because it's an equation that has an absolute value in it and a variable. Solve for x. What's x? 5. Is there another answer? -5, right? That's exactly how we solve absolute value equations. Okay? What we do is we create two equations because I'm trying to find, okay, what positive value would make this 5? What negative value would make this 5? -5. So what I do, and I'll just start the first example here, because we're asked to solve it both using algebra and graphing. If this whole thing works out to 5, that will be a solution, because then when I take the absolute value, I get 5. So that's one equation that figures out what x is. If this whole thing worked out to -5, that would also work, because when I take the absolute value, I get 5. So what we do is we create two equations where we take out the absolute value bars, and then we say, okay, it equals to the positive of this side, and it equals to the negative of this side. And then I just solve each one. So here, add 3 to both sides, x is 8. Here, add 3 to both sides, x is -2. So there's two possible solutions. Like radical equations, we have to check these. Because sometimes when you take out the absolute value bars, you'll get a solution that's not actually a solution. Do you remember what kind of root we called that? What that word was? Began with an E. It's a pretty long word. Getting there. EX. Extraneous. Yes. Okay. That means it's an answer when you solve it, but when you check it, it's actually not. So I do have to check. So, does the absolute value of 8 minus 3 equal 5? That's pretty obvious. 8 minus 3 is 5, and its absolute value is 5. So that's good. We're good there. Does the absolute value of -2 minus 3 also equal 5? Well, -2 subtract 3 is -5, and then when I take the absolute value, I get 5. So that one works as well. So both of those are good solutions. Okay. We will find sometimes we'll get one that doesn't work. So that's how we solve it using algebra. How do we solve it? By graphing. How do you solve any equation by graphing? And I've been trying to beat this into you. You graph each side of the equation, and you see where they intersect each other, the x-coordinates. That's like what we did with quadratic equations. We graphed the parabola, we graphed the line, we found the x-coordinates where they intersect. We do the same thing with absolute value. So what I need to do is, if I'm going to do it graphically, we're using the graph, I have to graph y equals x minus 3, which is the left side of the equation. And I have to graph y equals 5, Remember, in order to make it a graph, you got to put a y equals in front of it. Well, this one's pretty easy, pretty straightforward. What does this look like on the graph? Y equals 5. What kind of line? You know this. Well, if we graph y equals 5, is this where y equals 5? Yes? Where else does y equal 5? Here? Here, 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 forever? What kind of line? Horizontal. So that's the horizontal line. And yesterday we learned how to graph these, right? First thing we had to do was graph without the absolute value bars. And remember, if there's no squared in it, it's going to be a line. And how do we do lines? Slope intercept. What's the slope of this line? The number here, 1, or 1 over 1. That's the slope. What's the y-intercept of this line? -3. So I plot the y-intercept, -3, done that. And then I count out a second point by using the slope. So 1, 1 means up 1 to the right 1. So my line's going to look like this. And remember, you want to draw it accurately. But that's not the absolute value graph. What do I have to do to change it to absolute value? Flip what up? Everything that's below, yes. Okay, so this has to flip up, this has to flip up, and we see we get this. Another way you can show the graph, instead of having to use a different color, is just do this. That's another way you can show your work when you graph an absolute value. It's just cross out the negative, and then everything that's above is the absolute value. So we had to graph this, and then we had to put the absolute value bars in. Sorry, I have to separate those so it doesn't look like they're 11. Put the absolute value bars in. And, well, what's the x coordinate there? -2. What's the x coordinate here? 8. Which makes sense because weren't those the two answers that we got when we solved it using algebra? We got these two answers. So it makes sense that we should get the same answers on the graph. Okay? You're not going to have to worry about doing this. I just wanted to show you how we can use a graph to solve. Okay, we're going to focus on the algebra. We're going to focus on this. So what did we do to solve? We remove the absolute value bars. And make the left side equal the positive of the right side. So we did this. We took these out, and we said, okay, x minus 3 equals the positive of this, which is still fine. And then we created a second equation by removing, and I'll just use dittos, the negative of the right side. And then, like I said, with radical equations, you have to check your solutions. Okay. So let's look at a few equations. Okay. We're asked to solve this. Actually, one other thing I should have mentioned, you got to have the absolute value expression by itself before you start making your two equations, which this is. So what's my first equation? I take out the absolute value bars and it equals the positive of this side, which is just the same thing. My second equation, I'm going to take out the absolute value bars and make it equal to the negative. And it has to be the negative of everything on the right. And now we solve each one. So I can add 3x, and I get 5x minus 5 equals 10. Add 5 to both sides, I get 5x equals minus 5 equals 5. Jumped ahead of myself there. 5x equals 10, x equals 2. That's the potential answer. This one, you have to apply the negative to everything, so we get negative 5 plus 3x. Take the 3x over and I get negative x minus 5 equals negative 5. Add 5 to both sides and I get negative x equals 0. And then how do I deal with negative x? Well, just change the sign here and change the sign here. Well, if you change the sign here, nothing changes. So it's still 0. So that's another potential answer. But in order to confirm those answers, I have to check them. So, does the absolute value of 2 times 2 subtract 5 equal 5 minus 3 times 2? What does this work out to? And then take the absolute value, 1. How about this sign? Negative 1. They do not equal each other. Okay? So, no good. Let's see if 0 works. Does the absolute value of 2 times 0 minus 5 equal 5 minus 3 times 0? 2 times 0 is 0. 0 subtract 5 is negative 5. And what's the absolute value of negative 5? 5. 3 times 0 is 0, and 5 minus 0 is also 5. That's a good solution. That one works. Okay. So this one only had one solution. This one. What'd be the first thing you do before making two equations? Yeah, we can't make the two equations until this expression is by itself. It's got a plus 12. So we've got to move that first. Now we can make the two equations. Okay. So I want you guys to go ahead and finish this. Just sort of do this slowly so that you stay ahead of me. Your equations should look like this. Okay. Somebody have the answer as to what this worked out to? 1/3 is correct. And this one? Sorry? 4? We're going to get 7/3. And now we have to check. And let the fractions go in. And what's 3 times 1/3? 1. So we get 1 minus 4, which is the absolute value of -3. And I still have to add 12. Well, do these sides equal each other? No, because this is going to be 3 plus 12, which is 15. That is not 9. That does not work. Three times 7/3 is just 7, so I'm left with 7 minus 4, absolute value around that, plus 12. Does that equal 9? Well, once again, we get 3. Absolute value is still 3, plus 12 is 15 again. And no, that doesn't equal 9 either. So both of these don't work, which means we have no solution. Which actually makes sense if you look at this equation. Like, what value of x could I plug in here? Like, whenever I take the absolute value of this side, no matter what x is, it's always going to be positive, right? So that means it can never equal -3. It's impossible. Okay? So if you can recognize that even beforehand, you can say, oh yeah, there's going to be no solution. And we've just proven it. The last one. Well, the absolute value expression is by itself, so I can take it out, make it equal to the positive of the right, which is just the same thing. Make it equal to the negative of the right-hand side. And then I got to solve each one. What kind of equations do I have now? Quadratic, right? Because x squared. And I've got x terms, which means I have to solve by factoring. But before I can factor, I'm going to bring everything over to one side. So I'll do that for both of them. Notice they're slightly different from each other. I'm shaking your head because you can't get it. And that's absolutely correct. Okay. So what happens when we can't factor it? Quadratic formula, which is negative b plus or minus b squared minus 4ac over 2a. We have to do it this way. So b is negative 2, so when I plug it in here, it becomes positive 2. And then negative 2, you need those parentheses. 4 times 1 times negative 1, all over 2 times 1. What does this work out to inside? 8. Because this is positive 4, this is positive 4. Don't tell me to cancel the 2's because you're going to kill me if you do. What do you do instead? You just cancel the 2's. Why would you hurt me so? Right, and you did, because you told me the answers were plus root 8 and minus root 8.
I meant like we did like 2 cases, and then I made 2 and then plus 8 over 2, and then 2 minus 8 over 2.
What happened to the root?
You take it out.
Plus or minus cancels out square roots.
Oh wait,
Oh yeah. Come on.
it would be root 8.
Hey, she's putting herself out there and she's trying. Good for you. That sounded like a sarcastic yay. I hope it wasn't. Okay. Jenna.
2 root 4. But
Oh, you got the right idea, but you just simplified it incorrectly. 2 root 2. Remember, you got to simplify this. Highest perfect square is root 4, so it's root 4, root 2, 2 root 2. Now what can we do?
Cancel.
Cancel the 2's. And we're left with 1's. So we've got 1 plus or minus 1 root 2, and we don't have to write the over 1. That would be extremely ugly to check. Because imagine having to put this back in here, and then you'd have to square that expression, and then you'd have to do this, and then you'd have to absolute value it. Incredibly difficult, which is why I would not ask you to. Okay? We're just going to assume it works. Okay? I wouldn't, because that's a lot of work. So there's 2 answers. That when we assume that when we check them, they work. Fortunately, this side you can factor. So we don't have to do the quadratic formula. What would we get? Yeah. Which means what are my solution or solutions? X equals 1, just 1. Now that would be much easier to check. We'll assume it works. Okay. Okay,